One of the most common problems that people run into is either an overcharge or undercharge of refrigerant. And we get some questions about how to charge a system up with measureQuick and how to use smart probes. I thought we'd go over that a little bit today. So I've got a system set up here. I've got the project up and running, and there's always some things you want to do preliminarily before you start doing charging. Number one is you got to let Waffles out. You coming? Come on. He gets all upset if you leave him in the office while we're doing video work. And after you get Waffles outside, then you can start with the important things. So you never ever want to add charge to a system before you've done a couple of quick things. Number one is we want to come over here and I want to check the filter. So in this case here, I've got a brand new filter installed in the filter rack here, but I want to make sure I've got a nice clean filter in there, because a dirty filter will give you low airflow issues, and low airflow issues are going to make the system not work properly. I want to make sure I've got my return air probe in my airstream. You can see I've got it here on the register here, so it's a real good sampling spot. I've already checked my blower, so I'd go in here, pull apart my blower, open the cabinet, make sure that the blower's clean, and the blower's clean on here, and then a visual examination of my evaporator coil. In this case here, I can open up that filter door. I can actually look up inside. And if you can look up inside and visually see it, that's great. You can test pressure drop across it, but you do want to look at the evaporator. While you're looking at the evaporator, we also want to know if it has a TXV. Now, I have a rag wrapped around this because we're showing some things with the TXV, like if you add heat to it. But whenever you have a TXV, you're going to have the TXV bulb, which I have mounted here, and you'll visually see it's a TXV. That's our external equalizer, which is just measuring pressure at the outlet of the evaporator. So I want to make sure those things are good on there. And obviously you want your bulb insulated. So normally what I'm trying to do here is demo what happens when you have an uninsulated bulb, and that's why I have the rag on there, just so we can do some stuff with training on there. So now that we got those things done, I've got a couple of different probes hooked up here, and I'm measuring my suction line down here at the suction line service valve. I've got my low pressure here on the true suction line right after the reversing valve, liquid line temperature, liquid pressure right here. I've got a valve corded pressure tool on there, and I got a discharge line temp. I've also got a T on here, and those come in a lot of different flavors. This is what we call a charging T, and it's got Schraders in both ends of this so that you can hook this up, and then you can hook your probe to one side and hook up your tank of gas to the other here. So that's what we have going on there. Now, I went through and I did a couple of things here. In the electrical section, what I did was I captured my evaporator fan. So you can see my evaporator fan here is 229 watts of power. And you'll notice down here my condensing unit is a variable right now because I'm just watching the watts live come in. And I'm doing that so I can look at my real-time EER. So I tap on performance here. I could actually do it this way. I'll just tap on the button down there. I'm running about 11.2 EER and about 12.5 SEER. I just want to see if there's going to be a change in the SEER as I go through and do that testing. So all that looks pretty good here. If I tap on my outdoor measurements, you can see I got a 54 degree suction line, 11 degrees of superheat, 0.6 degrees of subcooling, and a 90 degree liquid line. If I tap on my diagnostic flag here, it's showing me that I have either refrigerant undercharge or I have a TXV that might have lost its charge in its bulb. Now, measureQuick is all probability based, so the highest ranking problem on there is the typical problem you're going to find. In this case, it's an undercharged system on there, so that's where I'm going to start at on this piece of equipment. Now, what you want to do here, I've got a tank of 410A, and I'm going to turn this guy on here. I always want to clear my hose and make sure there's no air in that hose, and then I'm going to go ahead and hook this up to the back of my charging port right here. All right, so now I got this valve here that I can open up and add refrigerant in. Now take the tank on 410A, you always got to turn it over because the refrigerant is a blend and it's got to be charged correctly on there. You got to make sure that you have the blend that goes in as a liquid. A couple other things I want you to notice here, if you can come over here and take a look at this, you'll see the sight glass over here is just filled up with bubbles right here. Another indication, a lot of times you can put your hand on the line and actually feel those bubbles going through here. That's a very good indication also that we have an undercharge. So what we would do in this case here is we'll look at that again when we're all done, and that should clear right up on there. So let's take a look at a couple of interesting things here on our application here. So you can see, and this is where guys get screwed up a lot of times. You can't evaluate a system just looking at pressures, because our pressures are pretty spot on here. We have 126 pounds on the low side, 280 on the high side. The high side's right on the edge of being a little low. Suction line temp looks good, superheat looks good, because this machine, even though it's low on charge, it's getting enough liquid that it can actually work that way. Our subcooling at 0.6 tells us we don't have enough liquid in there for sure. Our liquid line temperature is high, which is also an indication of an undercharge of the system. If we scroll through here, a couple other things. Our approach is 16.1 degrees, meaning that our approach temperature is much higher than it should be. Our outdoor air is 74, so we're in a good temperature to charge, but at 74 degrees, we are way less than full load on this equipment. So while this equipment's working fine today in 75-degree weather, a 95-degree day is when it's going to start to fail. So we got to make sure we get that charge correct. Compression ratio looks okay, discharge line looks okay, return air, wet bulb and dry bulb and humidities and stuff look okay. Our airflow is at about 593 SCFM, temperature split's okay, and overall our capacity looks pretty good. Everything there looks fine. But our EER is on the low side, but we'll see where it is when we end up. But at the end of the day, this system is low on gas, and we got to get it charged up so that it works on a design day. So what I'm going to do is I'm going to go back to the readings here, and this unit I went through and set up a test on here just to show you this. I'm going to go back into the project here, hit back, and go into the equipment information and system profile. This is a 1.5 ton system, 410A, 400 CFM per ton, 1316 SEER. It's got a TXV, which I showed you earlier. Oversized evaporator coil. This has got a 1.5 ton with a 2-ton evaporator. A target of 18 degrees on the subcooling. Now, your subcooling target in measureQuick defaults to 10 and 10. And 10 and 10 is a very typical subcooling value. When we come over here and we look at the chart on this thing, the manufacturer calls for, on a 75-degree day, cooling mode, 75-degree day, it's actually 19 degrees of subcooling on here. Now, another thing to note on this is that the tolerance of that subcooling is plus or minus 1.5 degrees. This is a heat pump, and heat pumps have a much higher, much lower tolerance to incorrect charge than an air conditioner does. So we're going to go ahead, we'll change that to 19 degrees so that we got that number correct, and we'll go ahead and hit submit. But you always want to make sure you're using the manufacturer's charging chart and getting the equipment set up properly. So now I'm going to go ahead and hit the home screen again here, and I'm going to go back to my superheat and subcooling, and I'm going to slowly start to input the gas. Now, you want to take this valve here and you want to sort of throttle the gas in. You want to take it in slowly because we're putting liquid basically right into the suction line here. So I'm going to open this up, let this go in a little bit, and I should start seeing my pressure increase here. And I'm not, so let me make sure my tank is on. Let's see here, that looks good. And that may not have been on tight enough. All right, so I can feel this pulsing on my leg here a little bit. We're adding in liquid slowly here. And what I'm going to watch is I'm going to watch my subcooling, and it's going to slowly start to increase as we get some refrigerant into the system. And I'm taking this in relatively slow because you don't want to overcharge the system. Now, some heat pumps, when you work on them, they're going to have, I'm going to throw this off for just a minute, let it settle out. Some heat pump systems have an accumulator. An accumulator goes in between the suction line and reversing valve, and it's just literally a tank, so that when liquid would come in, it doesn't go into the compressor, it drops to the bottom of the accumulator. If you have an accumulator, it's very, very easy to overcharge the system, because when you dump liquid in, it's going to end up at the bottom of the accumulator, and there's no heat to boil that refrigerant out, so it boils out very, very slowly. And what you'll see is this gradual rise in subcooling, and eventually what it'll do is you'll overfill the condenser and you'll have an overcharged system. So if you have an accumulator, you got to look down in there. If you got that, you even want to charge a little bit slower. Charging is not something you want to rush. You want to take your time doing it, because if you overcharge the system, then you got to take the gas back out, and it's just a waste of money. So we want to get this charge right on here. So you can see my subcooling's gone up from 0.6 to 1.8. It's starting to climb a little bit, so I'm going to go ahead and add a little bit more gas in the machine. Now what I'll do is add gas till I see this subcooling coming up to probably around 10 degrees or so, and then I'll throttle it back down again. So we're up to 4.4, 4.8, 5.0, 5.1, 6.1, 6.6, 6.7, 7, 7.4, 7.9, 8.5, 9, 9.7, and we'll just throttle it down here for a minute. You got to remember, when I'm adding gas in, I'm adding it into the suction line of the compressor. It's going through the compressor, it's getting discharged into the condenser. The condenser then starts to fill up with liquid refrigerant. As that condenser fills up with liquid refrigerant, what's going to happen is I'm going to start also putting more refrigerant in my evaporator coil. The level goes up there, and basically the levels are adjusting between the condenser and the evaporator like this till we get the charge balanced. Literally, when we talk about balance, that means the refrigerant has leveled out, and it no more is migrating from one coil to the other. It's just sort of balanced out in there. So when we start filling the system up, initially it's in the condenser. If our evaporator's starved, it's going to start filling the evaporator. Now this one's not too low, but a couple other things have happened here. If you look here, now that we have some subcooling over here, our sight glass is starting to clear up on here. So we're right at about, you know, a clear sight glass, because now we've got 11 degrees of subcooling, but we still don't have enough subcooling for the system to be fully optimized. So that's, we're going to add a little bit more gas here. One of the handy things we can do is we can go to trends. So right now I'm trending my superheat and my subcooling on here, and we can see that my subcooling's starting to flatten out here, and my superheat is really nice and flat right there. My superheat's somewhere around, looks like around 12 degrees of superheat on here, and subcooling's flat. So now I can go ahead and add a little bit more gas to the machine here. And as I add gas, we'll start to see that subcooling increase again. So actually superheat, sorry, I had those backwards on there. Superheat was on the, about the 4 degree range on there, and the subcooling's coming up to about 15 degrees or so on there. So we're gonna, again, take that up, and I'm going to throttle it off and slow it down. So I'm watching for this line to flatten out here and make sure I don't overcharge the system. Now what will happen a lot of times is when we're low on gas, is the expansion valve can also act like a fixed orifice, because it can be wide open on there. And the TXV's, its job is to maintain constant superheat. In this case here, the TXV's throttling, it's doing what it should do, but it's also got to have enough pressure drop across it. There's two things that happen. We have to have enough pressure across the TXV for the valve to operate properly, and then we also have to, you know, the valve has to have a liquid seal on it. And you know, once we get those two things, the valve should start to modulate properly on here. So again, we're right at about, let me get off the trending here for a minute, right about 16 degrees of subcooling, and we're still settling out here. We're still a little bit low on gas here. Our superheat's really low on this, around about 2 degrees here. We'll see if that valve starts to respond a little bit better here and stabilize in just a minute. But we're going to let that run for just a minute and see where things settle out, and just give it a couple minutes to just to see how things are going. So while this is running, let's take a look and see what our capacities are doing. Our sear's at 11.2 and 12.4, so I think we're just about where we're at, and it doesn't really surprise me any, because again, we're outside of design. It's not very cold out, or not very warm in here. Our performance, we are picking up some latent capacity, so we're at like 94% of our normalized, 97% of our sensible, and 85% of our normalized latent. Everything else looks pretty good there, so we'll see where the superheat and subcooling are, and we'll go ahead and get this a little bit more refrigerant here. to get that subcooling up to where it needs to go. Now again, when you're adding gas to machine, I can't overemphasize how important it is. Make sure your condenser's clean, make sure your evaporator's clean, make sure you have good airflow, make sure your filters are clean. Because if you don't have those things done right, nothing you're going to do with charge is going to get the system fixed. In fact, you're probably going to either overcharge or undercharge that system, because a dirty condenser or dirty evaporator or low airflow will impact the operation of the system. So we want to make sure that all those things are gone through and checked here. We're getting a little bit closer. We're at 17.9 degrees of subcooling, and we want to be within 1.5 degrees of this, so we're there right about now, but I'm going to tweak that up just a little bit more and get that charge as spot on as I can here. So we'll just give this a couple seconds to make sure it's settled out. Again, going back to the trending, I look at my subcooling line, that's just about as flat as could be. So as long as that subcooling line is flat, that means the charge is sort of balanced out here, and we'll go back, we'll just add a tiny bit more gas to get that subcooling up to 19 degrees. It's at 18 now, we'll just give it just a touch. And we'll see if we can get that up 1 more degree. You see our liquid line temperatures dropped down quite a bit, as did our approach. Our approach was 16 degrees, if you remember right now. It's down about 5.4 degrees. The discharge line's about the same. Obviously outdoor air is about the same. Our subcooling's well within range now. We're within 0.6 of a degree, and we're still climbing a little bit. We'll probably hit about 19 degrees on there. Liquid line temperature's a little bit high, just as the way we're calculating it now, but let's see what we got a diagnostic flag on here. Let me make sure I've got my profile set up right, just to make sure I didn't change anything. Yeah, all that looks good on there. And we'll just hit the home button. We'll give this a few more seconds to settle out. Now, on the diagnostic flags here, we're getting the condenser may be dirty. It could be 2 symptoms of overcharge, and that TXV bulb may be loose still. I'm going to tighten that rag up on here and make sure that I'm getting a good contact with this insulation on here. And loosen that up there. It may be picking up a little bit of room heat. So we'll just get that a little snug on there. We'll see if that starts to go away. And a symptom, whenever you're looking at this thing, you always got to look at symptoms. Well, what are symptoms of an overcharge on here? Well, if you look at our minor faults, our liquid line temperature is too high, our condenser pressure is too high, or superheat's too low. Well, symptoms of an overcharge, the two it's seeing here are our liquid line temperature, the condenser pressure is too high and the superheat's too low. Those are symptoms, but it doesn't mean it's necessarily an overcharge. And then we got a condenser pressure is too high here, and the condenser pressure is too high and the suction line temperature is too low. So we know the TXV bulb's not loose, so I'm going to clear that out. And then I'm going to visually inspect my condenser here and make sure that nothing's dirty there. And this looks really good still. So I've checked it before. I'm going to clear that out. And then, we still got a couple faults here, but we'll just let this run for a few minutes and let's see if it settles out. We're right at 19 degrees on that temp split, and we're right on the threshold. In fact, it's just interesting here, literally just cleared out that fault went away. Again, all this takes time, so if you're rushing and making things, let me just go back here. I want to just reset the faults on here. So the only fault we're getting here is the condenser may be dirty, and the condenser on this is clean. And if I benchmark this system, what's going to happen here is it'll clear out that fault also. So what it's doing is it's calculating what the liquid line temperature should be, and it's saying the condenser pressure should be a little bit lower than it is, but I'm going to set a benchmark on here, and that benchmark is what it's going to do is tell that condenser that's exactly where it should be, and that liquid line, that's exactly where it should be, and this system's okay. So most important things: clean coil, clean evaporator, clean condenser, make sure everything's clean, make sure you have good airflow, and then make sure that you're charging slowly so you don't overcharge the system. Very, very important on there. You do not want to overcharge your system. And then let's see where we're at just performance-wise when we're done here. Hit performance. I'll do it this way again here. So now we're at 11.1 EER and 12.3. Again, not a huge change, but on a 90-degree day, this is going to be the difference between having a callback and having the system continue to operate perfectly. So hopefully that gets you through a little bit on the charging. And one last thing here, a lot of guys, they want to take their hose, shut off their tank, and bleed what's in their hose into their system. Completely the wrong thing to do. If I add the gas that's in this hose right now, which is all liquid, I'm going to overcharge my system. So you do not want to do that. What's in the hose is in the hose. What's in the system is in the system. I have my subcooling spot on, and I don't want to mess that up. So this is where I'm just going to disconnect my hose here. I got that disconnected now, and now I'd go ahead and remove my probes and it'll be done getting the system charged. So don't bleed that refrigerant back in. Don't bleed from the high side to the low side if you're using gauges. Not a good practice, because these machines are more critically charged than ever. And you can see with that label being at a degree and within a plus or minus a degree and a half of subcooling how important that really is. This is Jim with measureQuick. Thanks a lot for watching.